Hi everyone, I hope you're having a wonderful day and welcome to my video on decorators in Python. Decorators are a really useful way of extending the behavior of a function without having to modify its underlying implementation. You've probably came across decorators before if you've used a library such as Flask, and we can see here on line 5, this app.route that starts with a little @ symbol is an example of a decorator. To fully explain what decorators are, I first need to go over what a first-class function is, and also what higher-order functions are. And then afterwards, I'll explain a bit more in detail about what decorators are, and then how they can be used in practice. So a programming language is said to have first-class functions if functions can be treated just like any other variable. That is, they can be assigned to variables, or they can be passed as an argument to functions, they can be returned from functions, and so on. Pretty much every mainstream language now supports first-class functions, and effectively every functional programming language too. Higher order functions. So a function is said to be higher order if it either takes one or more functions as arguments or returns a function. So a higher order function is just one that manipulates functions in some way. And these are kind of academic sounding terms, but don't worry about it too much. It's just good to know for going on. So as a little example of a higher order function, let's look at this. I have a function here called apply, and this is our higher order function. It takes a function as an argument, it takes an x and it takes a y, and then it just returns the application of x and y to the function. So you call fn with x and y, and it returns it. Then we have these non-higher order functions here called add and multiply, and all they do is just add their arguments and multiply their arguments. And to invoke these, all we have to do is say apply to the add function the arguments 10 and 5, and apply to the mult function the arguments 10 and 5. We print out the results, and we get 10 and 5 is 15, and 10 times 5 is 50, which makes sense. And you're probably wondering, okay, that doesn't really do anything useful, it's a bit of a contrived example. But I'll show you here an actual useful example of a higher order function. So we have this higher order function here called log that takes a function and returns another function. And I'll explain this a bit more in depth in a second. And then we have these functions from the previous example, add and mult. And then all we're doing here is saying add is the result of calling log with the add function. What this does, it returns the wrapper and assigns that to add. The same with the mult function. Return the wrapper, assign it to mult, and now whenever we invoke add, so we call it like so, it starts to invoke this wrapper. So we get the name of the function, which in this case will be add. We say calling add with the arguments like 5 and 10, and then we return the result of calling add with the arguments that were supplied. And we do the same for mult here, and I won't go through it again. And all we do here is print the results. And now it says, here's the logging, calling add with arguments 10 and 5, calling mult with the arguments 10 and 5. And then here's the console logs of the actual results. So we've managed to add a little log to every call of these functions without having to modify how add and mult are actually implemented, which is pretty useful to be able to do. Again, this is a bit of a contrived example. Moving on. So decorators are just a bit of a syntactic sugar that make creating and using these high order functions a little bit nicer. Syntactic sugar doesn't actually add anything new to the language, it just makes it easier to express certain concepts or do certain things. So let's rewrite the previous example using decorators. So if we look at this log function, it's the exact same function as before, except now instead of doing add equals log add, we just add a little decorator that says, wrap this add function with the log. And the same for mult. We just add this little decorator above it. And now whenever we call add, it'll automatically wrap it in this wrapper function. And it produces the exact same output as the example before. And just as a final example, here is a way that we can use decorators to time how long a function takes to execute. So I have this little timer here, and I'll explain how it works. We're defining an inner function called wrapper. We get the name of the function, we get the start time, and then we actually call the function, and then we get the end time. And the elapsed time is just how long it took between the end and the start. So it might be, a few seconds, a few minutes, it could be anything. And now we just print the result. So we say the function took, elapsed to 4 decimal places second, and then we return the result. So I have a little example of a slow function here that just goes to sleep for 5 seconds, and then afterwards it prints that the slow function is finished. And if you noticed, there's a decorator that says, use the timer function. When we call it, it'll take 5 seconds, and then after 5 seconds, it'll print out that the slow function is finished and that the function took 5.0001 seconds. And this little fraction of a second is probably just having to print out that the slow function is finished. So there's a little intro to what decorators are, how they're related to higher order functions, and how you can use them to implement something actually useful. If you have any questions, please leave them in the comments below. And yeah, thank you for joining me today. Have a nice one. Bye.